Hello students, Mr. Sims here. This is lesson 2. In this lesson today we're going to look a little bit more deeper at parabolas. So the first lesson talked about anything with an x squared is considered a parabola. So the objective of the lesson would be the objective of this lesson is to determine if a parabola opens up or opens down. Okay, so if something opens up, it's going to have a minimum value, and if it opens down, it's going to have a maximum value. In the last lesson, we talked about how to find that minimum and maximum off of a table and even off of a graph. So, all right. So the graphs of quadratic functions are more complex than linear and exponential because they include a turning point that is either a maximum or a minimum. Okay, maximum would be if the parabola opens downwards, it has a high point. Minimum would be if it opens upwards, it's a low point. Okay, so today we'll explore these functions more by our calculator technology. So you're going to want your graphing calculator. If you don't have a graphing calculator, I believe last week I sent you guys a link to an online graphing calculator that you can access as you are going through this, but as you're following along, I'll just pop up my screen so you can see exactly what I'm looking at. All right, exercise 1. Consider the simple quadratic function y is equal to negative x squared. So we're going to write this parabola in the form of y equals ax squared, where a is the leading coefficient. Now, one thing that we've always known about variables is if there is not a number in front of the variable, we just assume it's a 1. So what this really is, negative 1 times x squared. Right? So if I were to actually do this, this means negative times negative 3 squared, which would be negative 9. Okay? Now, not very often are you going to be asked ever, actually probably never, to calculate the table by hand, so I'll just go right to the table to save us some time. Clear out the mess that I have in there, and I'm going to go negative x squared. And I'm going to go right to the table, and you can see that negative 3 is negative 9, and then we get negative 4, then you get negative 1, then you get 0, then you get negative 1, then you get negative 4, negative 9. All right, so now what we're going to do is we're going to go ahead and graph this next here. Graph the parabola given in this table on the grid below. What is the range of this quadratic? So let's plot it. So negative 3, negative 9, left 3, down 9, 1, 4, 5, 6, 7, 8, 9. Negative 2, negative 4, left 2, down 4. Negative 1, negative 1, 0, 0. And one thing, the more work you do with these parabolas, you start to pick up on the pattern. I did kind of breeze through that relatively quickly, but here it is. And the range of the function. Remember, the range is the interval over the y-axis. Okay? And really, all of the y values less than or equal to 0. Because this parabola will keep going in both directions. Okay? So the highest value is 0, and then the range would be everything below. Alright? So, some parabolas are concave up or will open upward, and some are concave down, open downward. That word concave has to do with, like, you ever heard of like a concave mirror? Like sometimes glasses that some of you wear, are considered like concave or convex. Basically, what I mean is concave is when you have something that like opens inward. Convex is like when it opens outward. So like if your lens looked like this, that's convex. A concave mirror is one that looks like this. Okay, a little bit of vocab there for you. Not really relevant to the lesson, but you get the idea. So in exercise 2, what we're going to do is we're going to use graphing calculator with a standard window. I'm going to sketch each of the following. All right. So when I say sketch it, you see there's no scale. First thing I'm going to have to do is I need to go to my window, and I can see my window is set. So if I press zoom standard, I have my standard graph. All right. So if I go in here, and now what I'm going to do is I'm going to type in 3x squared plus 6 x minus 4. And we're just going to look at the graph. And what you see is you end up with a graph that is over here. The minimum point is in, so it's somewhere, it looks something like this. Minimum point being in quadrant 3 in this case. Okay. All right, so you can see that this one actually opens up. All right, so then let's look at the next one. So clear this one out. We'll put negative x squared plus 6x plus 1. And I will go to the graph. And this one opens the other way. It looks like it kind of passes through here, goes up here somewhere, and then comes back down over here. Remember, these are sketches. These are not drawn to scale. If I were to draw this to scale, I would need the dashes, and I would actually use the points, the values. All right, and then let's look at one more. Y equals negative 2x squared. Delete. Okay, just clear. Sorry, I was trying to figure if I could do this a little bit quicker. Negative 2x squared minus 8x minus 4. Look at the graph here. And this one also goes down, and it looks like it kind of comes up over here somewhere and then back down over here somewhere, like so. Okay? All right. Now, the hope is that maybe you could be able to determine just by the equation, if there's something different in these equations, like this one is going up and these ones are going down. And hopefully there's a connection that you can make by looking at these equations. All right. If you got it, great. If not, we'll look at some more. All right. So exercise 3. Use your calculator to sketch a graph of each of the following quadratics using an indicated window. So we're at a standard window. So clear out. We're going to go y equals 2x squared. And look at the graph. And if you notice, a parabola that looks like so. Watch what happens when I'm gonna leave this graph on here, and I'm gonna put the next one in. So hopefully you'll see something here. 3x squared, and now look at the graph, and what you notice is it seems to be a little bit tighter. Right? And now I'm going to do 4x squared, so y equals, I'm leaving all these other ones in here, 4x squared. And look at the graph. And that one's even a little bit tighter. Okay. So they all look the same, but the differences are going to be in the tables. And we'll look more at that a little bit more specifically. I'm also just trying to think about what's the objective of this lesson. Now, if you look at these ones, now I'm going to go to these and I'm going to clear out what I got. And let's look at what happens when I do the negative. So I'm going to do negative 2x squared. And I look at the graph. Okay? Oops, you can't see it. My glare off of my window, or off my light. So you see that it looks very similar to the one up here, but it's facing down. Okay, so let's do negative 3x squared. Look at the graph. And you're seeing the same thing. The only difference is now it's facing down. As a matter of fact, I'm not even going to sketch these on here. Y equals, and then we'll do negative 4x squared, and you can probably assume that you end up with the same idea. Okay, the only difference is all of these are facing up. And what was the only thing that was different? This one was facing down. This one was facing down, but a little bit tighter. This one was facing down even a little bit tighter more. And what is the difference, really? Positive, negative, positive, negative, positive, negative. Which leads us to this conclusion that you can very quickly determine if a parabola has a minimum or maximum point by looking at the a term. So it appears we can now determine what controls the direction the parabola opens. For the quadratic, y equals ax squared plus bx plus c, fill in the blanks. The parabola will open upwards. In other words, it'll look like this. It'll open up. It'll have a minimum value if a is less than 0. Meaning that if the leading coefficient is negative, it will, sorry, pause. Okay, If it's greater than 0, positive. My mistake. Okay, I mean, you guys know I've made mistakes all year long. You can't expect me not to make them while I'm sitting at home here in Sports Center playing in the background, and I got my coffee next to me. And all right, now the parabola will open downwards. In other words, it'll look like this type of quadratic function, and will have a maximum value. So it'll open downwards if, now I got it, if a is less than 0 or negative. So you can tell very quickly by looking at a parabola. Like, let's say I gave you y equals negative 3x squared plus 2x minus 4. And I were to ask you, will this have a minimum or a maximum? Okay, so I'm giving you this as an example, and I've seen questions like this. Is they have a minimum or a maximum? Well, first of all, you find the leading coefficient, and if that's a negative, that means it opens downward. I don't know where, but it'll have a maximum value. And that is kind of the gist of the lesson for today. All right, so for recorded lessons, this is lesson 2. And then your assignment would be to do the next 2 pages, which I already have the answers on there because I made an answer key. You know, and if you need anything, don't hesitate to message me. Actually, something too I've been seeing is one of your classmates, one of you, submitted pictures. And like took pictures and sent them to me. You can take a picture of a problem you're working on, and you can send it to me, and I can actually see the work that you're doing. So yeah, keep that in mind as well. It's quite easy to do. You can even record a video and send it to me. You know, it's up to you guys. So all right, anyways, for lesson 2, this is Mr. Sims signing off.